Hey guys, we are continuing solving problems from Fundamentals of Physics by Halliday Resnick Walker. Mine is a torn one. We're solving it from 8th edition. Remember, you'll have same problems in your current edition, but with different numbers. Okay, with different numbers. This time we're solving problem number 22, chapter 21, based on Coulomb's law. I'll just read out the question. Figure A shows an arrangement of three charged particles separated by distance d. Particles A and C are fixed on the x-axis, but particle B can be moved along a circle centered on particle A. During the movement, a radial line between A and B makes an angle theta relative to the positive direction of x-axis. The curves in figure C give for two situations the magnitude of the net electrostatic force on particle A due to the other particles. That net force is given as a function of angle theta and as a multiple of a basic amount f0. For example, on curve 1 at theta equal 180 degrees, we see that net force is equal twice f0. Part A. For the situation corresponding to curve 1, what is the ratio of the charge of particle C to that of particle B? So QC by QB we had to find out. QC by QB along with their signs, including sign. Part B. For the situation corresponding to curve 2, what is that ratio? Okay, what is that ratio? Okay, fine. So we are given three particles. Out of three particles, two are fixed. A and C are fixed. Now B, you can move along a circle around point O. Along a circle around point O. So A is the center for B's motion around point O. B's distance from A continues to remain same, D. So that means it moves in the circle with center at A. This line joining A and B is making an angle theta with the x-axis at any given time. So in the beginning, that line is making 0 angle with x-axis. When particle B is here, it will be 90 degrees. When particle B is on this side, it will be 180 degrees. Okay. Now, when you change the orientation of B, when you rotate B, the magnitude of force from B on A is not going to change. Magnitude does not change. Magnitude depends on the distance, which is the same. Charges A and B are the same. So magnitude of force on A from B will not change. But direction obviously will change. Okay, direction will change. So if A is here and B is here, let's suppose B is unlike A, so B will attract it. But then when B is here, so it will attract it this way. When B is here, it will attract it this way. So direction of that force changes. Well, if direction of one force changes, then net force, because A is not experiencing only this force, A is experiencing force from C also. So net force on A will change. Okay, magnitude, both in magnitude and direction. Now, how does that change? Net force, how does that change? By rotating this particle B as a function of theta. How does that change? We are given two curves, curve 1 and curve 2. So two cases are there. We are to find out this ratio QC divided by QB along with their signs. Okay, along with their signs. So we'll first deal with curve 1. Okay, we'll first deal with curve 1. Okay, so let's deal with curve 1 first. Now, note one thing, the scale on y-axis, the force scale, is multiples of f0. So this 1 stands here for 1 times f0, and this one stands here for 2 times f0. And from 0 to f0, we're having 4 divisions. So each division corresponds to f0 by 4. So we'll have f0 by 4, then twice f0 by 4, then 3 times f0 by 4, then 4 times f0 by 4, which is f0, 5 times f0 by 4, 6 times f0 by 4, 7 times f0 by 4, 8 times f0 by 4, which is twice f. Okay, now let's deal with case 1, curve 1. Curve 1. Well, curve 1 tells you that when angle is 0 degrees, that means when particle B is here, as shown in figure A, when particle B is here, then net force on particle A is 0. Net force on particle A is 0. Well, that is sufficient for us to find out ratio QC by QB. So it's exactly the same. We have done problems like this before. Case 2 is different here. Curve 2 is different. Curve 1 is exactly the same what we have done earlier in earlier problems. So note that at theta equal to 0 degrees, force is equal to 0 on particle A. Meaning particle A is here, particle B is here, and particle C is here. A and B are separated by distance d, B and C are separated by distance d, D and D. Now, A is experiencing two forces, one from B and the other from C. For net force to be 0 on A, because at 0 angle, force is 0, meaning when particle B is here, net force on particle A is 0. The two forces need to be in opposite directions and equal in magnitude, but opposite in directions. So what must happen is one of the two particles must attract A and the other particle must repel it. For that, one of the particles must be like A and the other particle must be unlike A. Okay. So if I take A to be positive, then one of these two is positive and the other one is negative. Let's say B is positive and C is negative. Well, it won't matter what is the combination of the signs. Okay, it won't matter. After all, magnitudes must be same. So B will repel A. B will repel A. So force on A from B will be this way. And C will attract A. So force on A from C will be this way. Force on A from C will be this way. This is the only way. So one of the two charges must be like A, the other particle must be unlike A. That means B and C are unlike. B and C are unlike. Well, if B and C are unlike, then the ratio must be negative. The ratio must be negative. So they are unlike, one of them is positive, the other one is negative, so ratio must be negative. Okay, now for net force to be 0, these two forces must be now equal in magnitude. So FAC must be equal to FAB. FAC is gamma QA QC divided by A and C are separated by 2D distance, D plus D 2D. So, but we have to take square of that. So it will become 4D square. 2 square is 4. Then FAB is gamma QA QB divided by A and B are separated by D. So D squared. So we're almost done with this part. Gamma and gamma cancels out, QA and QA cancels out, D square and D square cancels out. So this means we'll find out QB by QC, right? No, QC by QB. We'll find out QC by QB. So QC divided by QB. QB I'm taking here downstairs. 4 I'll shift to the other side. That's all. So QC divided by QB comes out to be 4. But we already discussed that if these two charges are unlike, B and C are unlike, one of them is positive, the other one is negative. Now it doesn't matter which one is positive and which one is negative, but one of them is positive and the other one is negative. So the ratio must be negative. So if we write the same result with sign, then QC divided by QB is equal to -4. QC divided by QB is equal to -4. Okay, negative of 4. Why minus sign? Because they are unlike charges. Okay, because they are unlike charges. Is that fine? So now part A is over. Simple. We have done many problems like this. Part B is a bit different. Curve B, curve 2 is a bit different. We have to deal with curve 2 now. Okay, we have to deal with curve 2. So let's deal with that on the next page. So again, back to the same diagram. We'll be dealing with curve 1 now. Curve 1. No, curve 2. Curve 1 we did. We have to do curve 2. Now curve 2. Note that when angle theta is 0, meaning when particle B is here, force on particle A is here. That is 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5. 5 times F0 by 4. Remember, we already discussed one of the divisions is equal to F0 by 4. So 1 F0 by 4, 2 F0 by 4, 3 F0 by 4, 4 F0 by 4 and 5 F0 by 4. So at theta equal to 0, let me write that here. At theta equal to 0 degrees, force on A is equal to 5 F0 divided by 4. And then when theta is equal to 180 degrees, particle B is on this side now. So that angle becomes 180 degrees. So this is angle theta. This angle is 180 degrees, means particle B is here. So when particle B is on the other side of A, force is here. So that is 1 F0 by 4, 2 F0 by 4 and 3 F0 by 4. So this is 3 F0 by 4. Okay, so I'll write that here. At theta equal to 180 degrees, force on A is equal to 3 F0 divided by 4. And while taking it from 0 to 180 degrees, force is decreasing from 5F0 by 4 to 3F0 by 4. Force is continuously decreasing from 5F0 by 4 to 3F0 by 4. Meaning force is maximum at 0 degree and minimum at 180 degrees. Now, we are not displacing C. So distance between A and C, which is twice D, remains the same. So we're not changing distance from between A and C. Charge A is not changing, charge C is not changing. That means force magnitude FAC remain the same. Magnitude remains same. This one will remain same in direction also, because we are not changing anything. Okay, so this will remain same both in magnitude and direction. So we are concerned with magnitude here. FAC remain the same in magnitude. But then FBC, okay, FAB, not BC, FAB, force on A from B. We're not changing charge of A. We're not changing charge of B. We're not changing distance between them. Distance between them continues to be D. Okay, distance between them continues to be D. We're not changing distance between them. So charge is same, distance is same. So force magnitude will continue to remain same. So FAB remains same in magnitude. But what happens is direction changes. Okay, direction changes. Now, from the knowledge of vectors, you must know that resultant of two vectors A and B is under root of A squared plus B squared plus 2AB cos phi, where phi is angle between A and B. I'm not using theta because theta is used for something else. I'm using phi. Under root of A squared plus B squared plus 2AB cos of phi. And we know if we are allowed to change directions of A and B, then at phi equal to 0 means when A is parallel to B. Means when direction of A is same as direction of B. Then resultant is maximum, and that maximum resultant is simply A plus B. Is simply A plus phi becomes 0, this will become twice AB, then this will become A plus B whole square, square and root will cancel out. This is the maximum for resultant when two vectors are in the same direction. Okay, when two vectors are in the same direction. And at phi equal to 180 degrees, meaning A is in the opposite direction to that of B, anti-parallel to that of B. Meaning if A is in one direction, B is in the opposite direction. So A and B are in opposite directions. Well, in that case, resultant is minimum magnitude of the resultant is minimum and is equal to modulus of A minus B, magnitude of A minus B. So when two vectors are in same directions, resultant is maximum, A plus B, addition of the two. And when two vectors are in opposite directions, resultant magnitude of the resultant is minimum, which is equal to A minus B. So as you take the two vectors from 0 angle to 180 degrees, 0 to 180 degrees, force goes from maximum to minimum. And at maximum, the two vectors are parallel, that means in the same direction, and at minimum, the two vectors are in opposite directions. Now apply that here. Apply that here. Initially, as you rotate this B from this position to this position, only direction of forces change, magnitudes remain same, and resultant magnitude changes from 5 times F0 by 4 to 3 times F0 by 4. So it is maximum here and minimum here. When is it maximum? When two vectors are in the same direction. So meaning here in this situation, the two forces on A, one from B and one from C, must be in the same direction. Then only resultant is maximum. So we know resultant is maximum here. This is the maximum value. We know that this is the maximum value. So the two vectors, the two forces must be in the same direction. So force on A from B and C must be in the same direction. Now that same direction can be either both of them are leftward, rightward, or both of them are leftward. Whatever, they must be in the same direction. Then here the resultant of the two forces is minimum. And when is it minimum? When is it minimum? When two forces are in opposite directions. Okay, when two forces are in opposite directions. So we are given two situations. Okay, now we are given two situations. We have A here, we have B here, and we have C here. B is making an angle 0 degrees. And here in this situation, when theta is equal to 0 degrees, now theta is not the angle between two forces. Okay, theta is angle that the line joining A and B, that this line joining A and B makes with x-axis. Okay, when B is here, then that angle is 90 degrees. When B is on this side, then that angle is 180 degrees. So when B is here, meaning theta is equal to 90 degrees, the resultant of the two forces is maximum. The resultant of two forces is maximum, 5 times F0 by 4, meaning the two forces must be in the same direction. Two forces must be in the same direction. So either both of them are leftward or both of them are rightward. Either both of them are leftward or both of them are rightward. I'll take rightward. Okay, I'll take rightward. So force on A from C is this way, and force on A from B is also rightward. They have to be in same direction. You take them in rightward direction or you take both of them in leftward direction. It won't matter. Okay, it won't matter. So both forces are rightward this time. Meaning both B and C are attracting it. Okay, both are attracting it. That means both B and C must be unlike A. Then only attraction will be there. So if A is positive, then B must be negative. C must also be negative. Okay, C must also. Then only both of them will attract A. Then only both forces will be in the same direction. Now, if A is negative and both of these are negative, then both these forces will repel them. That will also work. Both forces will be in this direction. We need both of them to be in the same direction. That's it. So if A is negative, these two are also negative, then both will be this way. If A is positive and these two are negative, both will be this way. The point is B and C need to be like. B and C must have same signs. Okay, B and C must have same signs. Hi. So this is the situation at theta equal to 0 degrees. And since two forces are in the same direction, the resultant will have maximum magnitude. Okay, resultant will have maximum magnitude. So that resultant force on A will be FAC plus FAB, Okay, FAC plus FAB, and that is equal to 5 times F0 divided by 4. That is given to us. Okay, that's given to us. I'll solve it in a while. First, we'll talk about the other case. A is here. Now, C is here. B, you have shifted from here to here, so that this angle becomes 180 degrees. Now remember, A we have taken positive, C is negative, and B is also negative. B and C are like. C will attract it. Okay, C will attract it. So force is going to be this way, FAC. B will also attract it. So force on A from B will be this way. Now you can see the two forces are in opposite direction. Same magnitude, but now they are in opposite directions. So their resultant will be minimum. And what is their resultant? FA in this case is equal to FAC minus FAB. This minus this thing. They are in opposite directions. And this thing is equal to 3 times F0 divided by 4. From the graph we know that. Okay? From the graph we know that. The maximum force between them is 5 times F0 by 4. Let me erase it a bit. It is messy over there. Okay. So you can see here maximum force is 5 times F0 by 4, and minimum force is here 3 times F0 by 4. Okay. So now let's deal with this case now, the maximum one. This implies force between A and C is gamma QA QC divided by A and C are separated by 2D distance. Remember that? And 2D square is 4D squared, plus this one is gamma QA QB divided by A and B are separated by distance D. So I'll write D square is equal to 5 times F0 divided by 4. Okay, 5 times F0 divided by 4. Now we'll massage this equation a bit. So this implies I'll take gamma QA by D square by 4D square common. We're left with QC here and 4 times QB. We have taken 4 common and 4 is not here. So this becomes 4 times QB is equal to 5F0 divided by 4. So this implies QC plus 4 times QB is equal, I'll shift all this to this side. By the way, 4 and 4 cancels out. So this will become 5F0 D square upstairs, D squared, divided by gamma QA downstairs, gamma QA. So this is our first equation. QC plus 4 times QA. Let me cross star. QC plus, yes. So QC plus 4 times QB is equal to 5 times F0 D squared divided by gamma A squared. Call this equation 1. Okay, call this equation 1. Now with this one here, the minimum situation, when force between them is minimum. Okay, so again the same thing, we just have minus sign here, and instead of 5 we have 3 here. Rest is everything same. So this is gamma QA QC divided by 4D square. Remember, distance between A and C is 2D. So 2D square is 4D square minus gamma QA QB divided by D square is equal to 3 times F0 divided by 4. Again the same thing what we did earlier, gamma QA divided by 4D square common. We're left with QC here minus 4 times QB here is equal to 3 times F0 divided by 4. So this implies QC minus 4QB is equal to 4 and 4 cancels out, 3 times F0. This D square will shift to the other side, it will go upstairs, divided by gamma QA. Gamma QA. Okay, this thing is not there. So this is our next equation, equation 2. Okay, equation. So we have two equations for QC and QB. Now we have to find out ratio of QC and QB. Remember, we already concluded that B and C are like. Both of them are unlike A. So that means B and C must be like. So both of them are negative. We have shown that here. Negative and negative. So their ratio will be positive. Okay. Their ratio will be positive. Now what we'll do is, where is our equation 1? This thing is square. Equation 1 is here. So we'll divide 1 and 2. We'll divide 1 and 2. 1 divided by 2 implies 1 is QC plus 4 times QB, left hand side of 1. Then left hand side of 2 is QC minus 4 QB. So divided by QC minus 4 QB is equal to right hand side of 1. Right hand side of 1, 5f0 d square divided by gamma qa. 5f0 d square divided by gamma qa. And then right side of equation 2 is 3 times f0 d square divided by gamma qa. So into gamma qa divided by 3 times f0 d square. We're reversing it. Okay, it's actually here, the whole divided by, then we're reversing it. Gamma and gamma cancels out, qa and qa cancels out, f0 d square cancels out. Now look here, I'll divide numerator and denominator by 4 qb, both of them, numerator and denominator by 4 times qb. This will become qc divided by 4 qb plus 1. Then whole divided by, this will become QC again divided by 4 QB. This will become minus 1 is equal to, what we have here is 5 by 3. 5 divided by 3. Now cross them. 3, even this will become 3 times QC divided by 4 QB. Plus 3 into 1 is 3 is equal to 5 times QC divided by 4 QB minus 5. Okay, minus 5. So this implies, I'll shift 5 to this side, 5 plus 3 is 8, is equal to, I'll shift this to this side, 5 minus 3 will become 2. So 2 QC divided by 4 QB. This is 2 into 2. Taking 2 to this side, we're left with QC divided by QB is equal to 8 into 2 is 16. 8 into 2 is 16. Remember, we already concluded that in this case, both of them are like. Okay, and we took both of them to be negative. So if we take it with sign, if we write this equation with sign, then QC divided by QB is equal to plus 16. Okay, plus 16. Is that fine? Okay.